How does a router obtain its IP address? So let's assume I connect a secondary router to my first. An Ethernet cable from one of the LAN ports to the secondary router's one. Now, how does my secondary router actually obtain its IP address? Is it through DHCP protocol or any other? The reason that I ask is that, when my ISP upgraded my first router, it's also a modem, firmware, apparently according to them I had to bridge the second router through its LAN interface 4. There's no possibility to assign an IP address manually to this interface. They started use the concept of DMZ somehow misleadingly. However, when I configured the first router to bridge LAN interface 4 like they said, my second router started acting like a switch, even though it was connected through one. Although a DHCP server, Windows Server 2012, connected to the second router works perfectly fine, it receives an IP address from first router's DHCP and hands out addresses to its clients. So perhaps a weird question, but do routers obtain their external addresses differently from DHCP clients? From a theoretical standpoint, routers shouldn't be any different.
Many people don't realize that a consumer router is usually a number of components smushed into a single box. The WAN external ports are typically set to auto-configure using DHCP. That is, they will ask for an IP address, and then use it. Many people don't care what the external IP is, so long as things work. Hopefully this diagram will help to clarify some points, and hopefully I've drawn it correctly from your description. Each of the colored IP stacks will typically have a distinct IP address. Thus each router will have an internal and an external IP. The blue IP stack will have an IP address assigned by your ISP. Don't even try to configure it yourself. The green IP stack will have a private address, typically 192.168.0.024, or similar by default. You are free to configure this. The computer in router 1 will likely be running a DHCP server, and will lease addresses to clients on the network in this range. You can disable this. The red IP stack will follow on in a similar vein to the blue. It will likely request an address from the service provider, in this case, router 1. If, instead of LAN 4 of router 1 acting like a dumb switch, you have configured it to act as a bridge, then you might find that router 2's WAN port will try to get an IP directly from your ISP, not from router 1's DHCP server. I suspect this is not what you want, as you'll need to have provision from your ISP for 2 public IPs. It's not clear what you mean by my second router started acting like a switch. If you could now communicate directly with clients connected to router 1's LAN ports, then as has been mentioned before, this is typical. Router 2 would be masquerading, allowing its internal hosts to communicate with external hosts using its external IP. This is a standard feature of network address translation. Hosts on router 1's LAN ports likely won't be able to communicate with hosts on router 2's LAN ports. As a side note, the router 2 block in the diagram above is often marketed as a cable router, as many cable providers will supply their own external cable modem. This is just a marketing term, and it is of course possible to use such a router in this configuration, with an external DSL modem, etc. Equally, it is possible to purchase a router that contains a DSL modem, or a cable modem built in, as per router 1 above.
Typical home or small office routers typically, by default, use dhcp to determine what address to assign to their WAN interface. I think you're mistaken about your router acting as a switch. Likely, it operated precisely as it typically does, as a router. It likely was assigned one IP address by your modem/router for its WAN port, and it masqueraded for all the clients on its LAN ports, assigning each of them IP addresses by dhcp. This is precisely what it would do if the WAN port was connected to a modem.
Normally when you have two routers connected together, the second one retrieves its own IP address from the first router, and if you have DHCP switched on in the second router, then it will start handing out its own IP address to everything that is connected to it. In the same manner that the first router does from the ISP. The ISP gives the first router an IP address specifically for that router, then that first router starts dishing out its own IP addresses to any other device that is connected to it, regardless of whether or not the next device is a computer, or another router. The second router should have a specific port to plug into to use this, like a WAN port or a cable modem Ethernet port. Usually these are separate from the other ports. The second router in the chain should do exactly the same thing. It should retrieve an IP address from the WAN port and then start dishing out its own IP address from its own DHCP server. If you don't want it to do this, then you need to turn the DHCP off on the second router. That makes the second router act like a switch, and whenever a new device connects, it then goes back to the first router and asks for a new IP address. The only thing you've got to watch for if you're using the two routers, is that the IP addresses don't clash. Usually you'd set the IP addresses of one router to be something like 192.168.1.x and the second router to be 192.168.0.x with subnet masks of 255.255.255.0 on each. Subnet masks mark which parts of the IP address belong to which network. 255.255.255.0 means the first three parts of the IP address are referring to that specific network, and the final digit refers to the specific computer on that network, which ultimately means you can have 255 devices on that router before you run out of IP addresses. 192.168.1.0 to 254 or 192.168.0.0 to 254, depending also on what range you set on the DHCP. Changing the range and also changing the last number on the subnet mask can reduce this. That way router 1 would be giving out the IP addresses 192.168.1.x and router 2 would be giving out the IP addresses 192.168.0.x, and you shouldn't have a case where router 2's DHCP server gives out an IP address that router 1 has already given out.
If you want to support the channel, please consider subscribing.